Hello again, geometry friends. This is the second part of our topic 2 notes. And in this note sheet, I'm going to talk about how we can use our angle relationships to find missing angles in a diagram and justify our calculations. Okay, so to start simple, it says in this diagram below, find the missing angles. So we can see we have a line DAC, a segment BC and BA making triangle ABC. So when I look at this, I have to start thinking about finding these missing angles. So I'm missing an angle right here. Let me grab my drawing tool. I'm missing this angle right here, and I'm missing this angle up here. Those are the two angles that I'm looking for. Okay, so first of all, I'm going to post this as a link as well, but you have this little justification sheet that will allow you to see the different angle relationships. But what I'm going to do is I say, okay, well, let me start, well, since I have a triangle here, but I don't know two of the three angles in the triangle, I'm going to start right here with this 130 degree angle, okay? And being that that's a 130 degree angle, I can say, well, I know that if this is a straight line from D to A to C, that's a straight line right here, that this whole line has to add up to 180 degrees. So 180 minus 130 means that this has to be a 50 degree angle. Oops, that doesn't look so good, but it's 50 right there. So now in terms of justifying my calculation, for the sake of this video, I already pre-wrote a few of these, and I'm just going to kind of like copy and paste. So down here at the bottom, I said, all right, here's some of the ones that I use most often. But these two angles form as a pair of angles, and they form this line or line segment DAC. So I'm going to use this reason right here. Let me grab my select tool. I'm going to use this reason and say up here, that linear pairs are sup. Now what I'm going to do to just make this for this one picture, I'm going to say have a set of parentheses. I'm going to say a 130 degree angle and a 50 degree angle. That's the pair of angles that I'm talking about. Okay. Now the next angle is this angle B. And now that if I want to find this angle B, I say, well, okay, what other relationships do I have? There's a couple ideas that you could use, and I'm not going to lock you into just one, but the one thing that I use often, and I'm going to use here again, is I recognize that I have a triangle, and in this triangle, I have now two of the three angles. So if this angle is 50 degrees and that angle 70 degrees, then together that's 120 degrees, meaning that since the three angles all add up to 180 in a triangle, this one has to be a 60 degree angle. Okay, so now to justify that, I'm using the three angles in a triangle add up to 180. Then down here below, I call that the triangle angle sum equals 180. So let me grab that. I'm going to copy it and I'll paste it up here as well. Okay, and this time I'm going to say which angles am I talking about? I'm talking about the 70 that I started with, the 50 that I found, and the then 60 that I used to calculate the third angle. So there's my two missing angles in the diagram, and that's me justifying those two angles. Okay, let's look at the next example. Now it says here in this diagram, find the missing angles again. This time I'm giving a little bit more information. It says, given segment PO is, this symbol says perpendicular to segment PM. All right, so let's start with this, that if I see the symbol, this symbol perpendicular, that segment PO, that's this segment right here, is perpendicular to segment PM, that's this segment right here. That means that, or I remember from topic 1, perpendicular lines means that there's a 90 degree angle right here that is calculated. So I put a little box here for a notation to say that angle is a 90 degree angle. Okay, and there I'm asked to find the other missing angles, but specifically angle PMN. Let me say that I'll use angle PMN. PMN is this angle right there, and angle OPN, I'll use yellow. OPN is this angle up here in yellow. Okay, so now let's start to do some calculations. Well, all right, I'm thinking, well, what do I know? I've got a 64 degree angle but this angle right here is one of the three in that I don't know this one. Can I find this one? Sure, because this 95-degree angle, I have a straight line from M to N to O. There's a straight line. So if this is 95, this has to be the supplement or the other part of the 180 degrees there. So 95 or 180 minus 95 means I've got another 85 to go right here. That's an 85-degree angle. Okay, so I'm going to reuse my linear pairs are sup thing here. But this time I'm going to say the angles that I'm referring to are the 95 and the 85-degree angle. Now I'm going to continue finding some missing angles. So let me go back to my drawing tool here. This time I'm going to say, well, my next step, I'm thinking I'm going to find what this angle right here is, because I have an 85-degree angle in the small triangle PNO. I have an 85 and a 64. So that's the third angle in that triangle. So the triangle angle sum says that this angle has to be 51 degrees. Okay, so likewise, let me go up here. I'm going to reuse this same thing. This time I have some different angle sums, but I have the given 64, the found 85, and then the calculated 51-degree angles. Okay, so there's my next thing. All right, so there's line 2. Continuing on. All right, so now I'm looking to try to go from here to here. Now there's a couple different ways I could do this. So for one, I could say I have a triangle, 2 different triangles. One of them is triangle MNP, and the other one is I'm looking at the biggest triangle, MOP, that big triangle. So it doesn't matter which way you go, but one thing I recognize is knowing that perpendicular lines make right angles. I can say that over here. Now I didn't use that one yet, so let me copy it from down here. Perpendicular lines, perpendicular lines make right angles. And up here, I'm going to put that in here and have a 90-degree angle here. So I know the angle that's 90 is the angle MPO. Okay, but then following that, that means that if this angle right here is 51 degrees, that one right there is called the complement of it. A complement means the two numbers add to 90. So I'm going to grab my drawing tool, and 51 plus 39 is 90. So this is a new reason. I haven't used this yet. I didn't have that one prepared for this yet, but here it is. I'm going to say complementary sum equals 90, and I'm referring to the 51 and the 39-degree angles. Okay, so there's that one. Now I have just one angle left to find, and that's this angle right here. And that is the other one that I was asked to find in the beginning. That's angle PMN, and I'm looking at a 95-degree angle, a 39-degree angle, and then that's my third angle in that triangle has to be 46. Okay, so I'm going to now reuse the triangle angle sum idea from up here, but this time I have these three numbers, 95 and 39, and then I use that to find the 46. Okay, so that's my justifying my missing angles in this picture. One more to do together. Down here says in this diagram, again, we're finding missing angles. So I have 1, 2, 3, 4, 5 missing angles that I don't already know. I can see that this angle right here, GEB, is 82 degrees. This angle FBE is 140 degrees. So I can start just doing some calculations here and say, all right, well, straight line, FBD is a straight line. Okay, FBD is on a straight line. So if that is 140, this angle right here is the supplement of it. That one's got to be 40. Same reason, if this angle is 82, GED is all on a straight line, then this angle, the supplement of it is 98. Okay, so now watch what I can do here. I'm going to use this linear pairs are sup idea, and oops, Back up here. Linear pairs are sup. We're trying to copy it. There it is. Copy. Paste. This time I'm going to have a 140, 40, and I'm going to do 82 and 98. I'll put both of those in there for the same thing, so because I'm reusing that line twice. Okay, moving on. Now I see, okay, well, now I'm working my way inside this triangle. This is my method of thinking about this. So I'm going to use the triangle angle sum to find what this angle is right here. This one has to be 42, because if you've got a 98 and a 40, this has to be 42. Those three numbers have to add to 180. So let me get this up here. Copy triangle angle sum. He's always 180. And then I can write a text box down here and say this time I'm talking about these three numbers. We have a 40 degrees, we have a 98 degrees, and I have a 42 degrees. Okay. Okay, moving on. Now, I haven't used this one yet, but when two straight lines intersect. Now, there's really two types of relationships that we're talking about most often when straight lines intersect. Like, for example, one of them was when line FBD intersected with line EB. That created these two angles. That's a linear pair of angles. But now I'm going to look at a different one. This is when the line from G through to C intersects with line F to A, right here at point D. So I have this angle right here that's 42, but also the angle that's opposite of that, that's called its vertical angle. And one of the relationships that you need to know most commonly is that vertical angles are always congruent when lines intersect. So this one has to be also 42 degrees. So that's this reason down here that says vertical angles are congruent. Sorry, lights went off. There it goes. Okay, coming back up here. Text box. Vertical angles are congruent. 42 and 42 are the two angles that I'm referring to that I'm talking for that one. Okay. I see that we know perpendicular lines make 90-degree angles. I'm just going to copy and paste that one right here because I can see that I have lines that are perpendicular. And so I'm just going to include that. That's where that 90-degree angle came from, right over here. Right there, that one's 90. And then the last step is I'm going to do triangle angle sum a second time. This time 42 and 90 means this one over here has to be 48 degrees. That's angle A, or angle CAD is 48. So let me reuse that last one right here. Triangle angle sum is 180. And this time I'm just going to throw in the numbers 42, and then 90, and finally 48. And there you have it. So that's how I can use these justifications to find the different missing angles in diagram.